Alright, so first we're gonna need an integer array that contains the destinations of branching. So let's go ahead, int, and since the size of this array can actually vary and can go up to the same number of elements inside the imem array, we're gonna also make it be a pointer. So int waypoints. Alright, and then now it's not always going to be the same size of imem, so we're going to create a second integer that represents size. So this first one does size equals 4, that's for the iMemory. This one, let's call it waypoint count, and let's also start it at 4, and then eventually it's gonna double. We're gonna need another integer that pretty much says how many waypoints we currently have. So actually let's make waypoint count be that variable, and instead add waypoint capacity, which equals 4. Yeah, and then we'll look to where we've declared the imem. And then we're going to do a similar declaration for the waypoints. Waypoints equals int malloc, and then size of int times waypoint capacity. There, and then we're going to make sure that whenever the waypoints pointer gets filled up to its capacity, it's going to double in size, just like the imem does. Alright, so as you can see, this increase capacity method, which is used for the instruction memory, we're also going to want to do that for the branching memory, which is the waypoints array. Right, so increase capacity, we're going to just duplicate that increase waypoints capacity. Alright, and now we're gonna go up to the part where we see the capacity increase for imem. So increase waypoint capacity if the waypoint count is greater than waypoint capacity. And then now we're going to want the program to add to the waypoint array whenever it finds an instruction using the code way. So if the instruction says way 0, it's going to go to index number 0 of the waypoints array and then set it to whichever the PC is at. So right here, if string compare the up and then way is equals to 0, and we're gonna go into the waypoints array. The index is gonna be at number 1 of the instructions, which it starts at 0, so yeah, num's 0, equals the PC, which means it would actually, which in this case is I count. Oh, equals I count. Now, one problem with this though is that if you were to enter a number for the way instruction that brings it way up, let's say 6,000, it's going to largely increase the size of the waypoints array. So this might not be the best way. So instead of letting it be an array of integers, we're going to create another struct. Type def struct, and we're going to call it branch, and since we already have a method called branch, we're going to call it branch element, or abbreviated to branch elem, and it's going to contain 2 integers, one being the PC and one being its index. So if you were to enter 56,000, and then so that 56,000 is going to be the index of the branch element, and then PC is going to be assigned whichever number the program counter was at, so that it will know where exactly to branch to. So, and the waypoints is going to now be a pointer that contains a bunch of branch elements. Alright, and then be sure to change every declaration in malloc. Alright, so next, now whenever we see an instruction that has the code way, the index is going to be set at the waypoint count. So then waypoint count plus, and then it'll be set at the current waypoint. Okay, so let's do multiple here. Multiple lines. Waypoint count equals I count. Now, since it's not an integer array anymore, but now an object, is going to be dot, and look at the variables again. It has PC and index, so it'll be the dot index, and then the dot PC is going to be equal to nums 0. Alright, so now if the code was way 78, and then it happens, let's say, somewhere towards the beginning at line number 6, so the PC is going to be set to 6, and then index is going to be set to 78, and then for a branch instruction, if you want to branch back to waypoint 78 here, you would say branch equals, and then you compare your two registers, and then that third number is going to be the 78, since that's the index of way. Alright, and then we're going to look at the branch instruction. Yep, branch, and then now our latest opcode is 12, and that was for store, and so store is 12, and then way is 13, BEQ is 14. So is equal to 14, and we'll get to 13 later. Branch, and then that instruction, branch if equals to, and yeah, later on behind the scenes I'll add some more conditional branches, such as B and E, which means branch not equal to. Yeah, let's actually increase the number of branch ops, and yeah, I've separated the ops and also the strings here. Okay, B and E, branch not equals to, and then branch greater than, branch less than, branch greater than equals to, and then branch less than or equals to, branch not 0. So now, yeah, we have way more than 5. So we've got 3, 4, 5, 6, 7, 8. Now, as for handling the opcode of 13, which is waypoints, we don't actually need to do that here because we've already handled it at the part where we were looking through. See over here, if string compare, the op way equals 0, and then we already did all that over here. So yeah, we skipped 13. And then yeah, branch if equals to. Now onto the actual branch. Now we're going to compare two first numbers. So if inst.nums 0 is equals to inst.nums 1, and yeah, this is for the branch equals to conditional branch. So then it's gonna need another parameter actually up here, int branch type. So for example, if the branch type is equal to 0, then that's the branch equals to, and then if it's equal to 1, then it's the branch not equals, and then so on. So branch here, and then 0. So if branch type is equal to 0 and these two numbers are equal to each other, then registers 15 will now equal the index of that branch. So let's here's the branch element, so it's got PC and index. So then there's going to be a for loop where it looks through the branch array. So here, let's make this a block statement. For int, and yeah, let's set int dest for destination, and then int I equals 0, I plus plus, and then it's going to scan through the entirety of the waypoint count. And then it's going to look at the index of each branch elem struct inside the array, waypoints. So if waypoints I dot index is equals to the number we have, so instructions dot nums2 then dest equals to I, so then registers 15 equals waypoints I dot PC. Actually waypoints dest dot PC. Yeah. If dest is greater than or equal to 0, then it does this. It sets the PC to the waypoints dest.pc. And then back here where we had branch right here, yeah, if, and then there's going to be an if statement. If this opcode is less than or equals to 13, then it increments the PC by 1. Whoops, it seems I actually made a mistake right here. It's actually comparing these two numbers directly. It's supposed to be comparing the numbers inside the registers at these indexes. So I'm gonna go ahead and fix that. Registers inst num0 equals to registers inst nums1. Right? And it's also important that if the branch conditions are not met, we're gonna need the PC to increment by 1. Oh, and it also turns out there's a mistake right here where I've switched PC and index. Alright, so now let's fix that. So now PC equals to I count, and now the index, and this is for the waypoints, and their index is going to equal. Alright, and there's also another issue I fixed. So earlier I++ was in the middle, but yeah, it's supposed to be at the very end here. And I also did some manual debugging, and now the code actually runs great. Alright, because as you can see right here in the assembly code, yeah, it sets 5 to 65, register 1 to 99, all of that. Then 2 and 3 becomes 40 and 50, and then there's a branch equals right here, that if 2 and 3 is equal to each other, it branches back to 73. And yeah, in this loop right here, so there's add immediate to 10, so yeah, it changes this 40 into a 50. So then registers 2 and 3 are equal once they reach branch equals, so then it branches back to way, and then it adds 10 more to register 2, so then 2 becomes 60, and then now they're not equal anymore, and then it goes on to finish. So, oh, and here's the output. Yep. 50 and 50, and then it becomes 60 and 50, and it displays again 60 and 50. Alright, so now we've gotten the branching to work right, and then we can continue to do the same thing for other types of conditional branches.